My topic is interference. And interference, in the context of electricity and magnetism, has to do with a superposition of waves of light which result in constructive or destructive interference. When light waves in phase and with the same frequency overlap, the resulting wave at that point will have an amplitude equal to the sum of the two separate amplitudes. Um, I so basically I did two examples that kind of illustrate these two ideas of interference and these superposition the superposition of these waves of light waves in specific. This first example kind of is a play on Young's double slit experiment. It's pretty much the same thing actually, but this is how it's arranged. The first one is taken from the textbook, is problem 35.11, and I'll read it to you. This is taken from section 35.2, two-source interference of light. And the question reads, two slits spaced 0.45 millimeters apart are placed 75 centimeters from a screen. What is the distance between the second and third dark lines of the interference pattern on the screen when the slits are illuminated with coherent light with a wavelength of 500 nanometers? Coherent light basically means there's going to be light, like monochromatic light that is in phase with each other, coming in, or they have the same frequency as well. They're coming through these two different slits, and basically these slits are very thin and very short in length, so they are going to act like little point sources of light that are coming out as well. So they're going to emit waves that will come out in circular form. They'll have cylindrical fronts, and each one of these will have the exact same structures of waves coming out, and basically superposition will occur along or constructive interference, which is a form of superposition, will occur at all points where these two waves overlap and they are in phase with each other. So along the center line is where along the center line is denoted by m equals 0, is one point where superposition occurs. And this question is asking us for the distance between the third and second bands. So the equation for this is, or the equation from the point m equals 0 to the center of band y denoted by m is equal to the distance between the slits and the screen multiplied by the number, the m number, meaning like 1, 2, 3 is the integer number of which antinodal curve you're talking about, lambda, wavelength, all those three multiplied, divided by the distance between the two slits, which is 0.45 millimeters. And basically, if we want to find the distance between the third band and the second band, we do y3 minus y2, y3 being this total distance, y2 being this shorter total distance, and the difference between them gives us that distance we're looking for. So, after doing a little bit of factoring, we find that r lambda over d is equal to this distance right here. So what we find is, after converting all the distances just to meters, we find that it is equal to 8.3 times 10 to the negative 5 meters. And this makes sense because this distance essentially is just this distance from 0 to 1, or 1 to 2, 2 to 3. It's all going to be the same. They're just all multiples of m. Don't get this meters mixed up with this variable m. Another example I have is it takes the same concepts, but it shows that this is more of a real life example. This other one is like Young's experiment. It's more in a controlled environment. It's not really ever going to happen in your daily life. But here we have two different speakers. The same concepts of superposition occur here. And this question reads, or basically the situation. There's two different speakers, and there's a woman in the middle of it, and basically we want to know what is she hearing at this point in between the two speakers, and and why does she hear it? And the way I answer this question is she's hearing constructive interference, meaning that the two amplitudes are added. The amplitude from each speaker is added together to form what she's hearing at that point. And we know that there's constructive interference because where the distance between S2 and a point P subtracted by the distance S1 to a point, any point P, right here, P's being this woman, when the difference between those two distances equals an integer value that meaning 0, 1, 2, 3, or the negative of any of those values, then that's the point where constructive interference occurs. And since she is exactly in the middle, R2 equals R1, meaning they both are 7.5 meters. So 7.5 minus 7.5 is equal to 0. 0 is an integer, so constructive interference occurs. Alright, so that was easy enough. The next part of the question is, how far does she walk towards one of the speakers before hearing minimum intensity? Well, minimum intensity occurs where destructive interference occurs. Well, what is destructive interference? Constructive interference is where the distance between the sources of the waves to a point equals an integer. That's where constructive interference occurs. Destructive interference occurs where the difference between those two distances is an integer plus half, meaning m plus half lambda, or in other words, are half out of phase. So for solving this, we want to find the first value where R2 minus R1 will equals half. And this is when the woman walks 0.25 meters away from the center. That's where R2 was equals 7.25, R1 equals 7.75. And the difference between them will be the difference between them will equals half lambda. That's where destructive interference occurs. So the answer is she walks 0.25 meters. And yeah, thank you for listening to this this example walkthrough, and yeah, thanks.